Great. Here's an example from the homework problems in the book. It's 6.2, number 13. And it's a good example for the quiz, but there is a distinct difference from the problem in the quiz too that I'll mention. It's in the problem statement. It says find the volume of the region bounded by, and there's a curve, 1 plus secant x, and a straight line, y equals 3. And this one's different because it says rotated around y equals 1. So what that means is I'm going to have to subtract 1 a couple of times because it's rotated around y equals 1, which would be like a horizontal line right here. And it's different than the x-axis. Usually it would say rotated around the x-axis, so you can say compare to the x-axis problems when we did those. So it's very similar, but I'll have to be very careful when I find radiuses of the washer. That's skipping ahead because I need to figure out what kind of region this is. Is it type 1 or type 2? So I graph it. You can look up the graph to 1 plus secant x, or you can remember secant is 1 divided by cosine, so it's just the like 1 over all the cosine curve. So it has vertical asymptotes, and where cosine is 1, so is secant, and this is 1 plus secant, so it'll start off right at 2. That's 2, and it goes up from here. Eventually it goes to vertical asymptotes up there. It makes a little ball shape. And then y equals 3 is a straight line like that. So that's the y equals 3 on the y-axis there. So this is the region that we'll look at, and it does look like it's going to be type 1 because all the way along from left to right, if you cut it into vertical slices like this one, make it darker, it has the same line on top, the straight flat line, and the same curve on the bottom, the secant 1 plus secant x. If you tried horizontal slices, technically you could do horizontal slices on this, but what they would be going from and to on the left and the right would both be the curve 1 plus secant x. So, and what would that even mean? Well, you'd have to solve it for x, and then you'd end up having to use the inverse secant, but you'd have 2 parts of the inverse secant, so you'd have to figure out what those were. So it's possible to cut that up as a type 2, but much harder because you'd have to figure out what those 2 curves are. Sometimes they can cut it both ways, but one is easier than the other. So I'll cut it up as type 1, and then it's rotated around that y equals 1, so not quite the same as rotating around the x-axis. Instead, like this point, instead of rotating all the way around the x-axis, it'll just rotate around y equals 1, that dotted line, so it'll end up just down so the same distance on either side, just down to here. So if I rotate that, I'll get that circle, and then this circle there, and then the larger one. Run out of space. I have a better picture of this that I'll put on the PDF. This isn't too bad, but a little hard to see. It makes a washer because it's a type 1 and it's rotating around a horizontal line. It's usually rotating around the x-axis, but that's a horizontal line. This one's rotating around a different horizontal line. Let me pull that washer out of the picture there. Try and draw it a little better. So there's the whole washer, and draw a little 3D. And the center line of that washer is that y equal 1. And so we're interested in the 2 radiuses. There's the short radius that goes to just the inside of the washer. That's the part that we're going to subtract and get rid of. and then there's the longer radius that goes all the way to the top. So let's see, to there. All right, so the short radius changes as you go from left to right because of the curve. It starts out all the way up here, it shrinks down until it's the smallest here, and then it gets bigger again. And the short radius would be the 1 plus secant x, but it doesn't go all the way to the x-axis, it just goes to 1. So it's going to be 1 plus secant x minus 1. That is like that, just to show it more clearly. 1 plus secant x minus 1. And I'm subtracting 1 because I'm just finding that distance. It's going to be 1 plus secant x on the top, but then minus 1 because that's the horizontal line the height of the horizontal line that I'm rotating around. And then the longer one will be the top line, which is actually just 3 minus 1. So both of those do simplify. This one turns into 2. And that one turns into just 1 plus secant x minus 1 equals just secant x right up above there. So that's referring to there. So those are the two radiuses, the big radius and the small radius of the washer. So this shows why it's a good idea to actually think through the process instead of memorizing it, because when you have a different line that you're rotating around, you have to figure out what the two radiuses are. And then I can just put it together quickly because I know that dV, that's the little volume of the washer, will be the two radiuses, and the thickness will be dx. That's the thickness of the washer. So I'll have pi r, the big radius, squared, and then minus pi r, the little radius, squared. So I'll have pi times the big radius squared minus pi times the little radius squared and times dx. And so that's my dV. And so then here's the setup of the integral. I do need to figure out where these 2 points are here too. Let's see. That's a pretty quick calculation. I think I can fit it in right here. So the intersection points. I'll set the straight line equal to the curve. It turned in, this is an intentionally easy problem. Subtract 1 from both sides and you get, doesn't look like it, but it turns into 2. And then you remember that secant is equal to 1 over cosine. So you could do this in your head if you want. 1 over cosine equals 2 is the same thing as saying that cosine equals 1/2. I'll write it out. So 1 divided by cosine x equals 2. So that means that, no, that's not a minus sign, that's just a smear. Cosine of x is equal to 1/2. And then from the unit circle, cosine x equals 1/2, right at that point that's closest to the x-axis of the standard angles. That's negative pi over 3 and pi over 3. So this gives me the answers that x is equal to negative pi over 3 and positive pi over 3. And that's where these cross. There's negative pi over 3 and positive pi over 3 on this side. Right where the two endpoints. So now I can write the integral down for the full volume. The volume is equal to integral negative pi over 3 to positive pi over 3. And I can simplify this a little bit. I have pi in both terms there, so I could just multiply by pi. and then 2 squared is 4. So to save myself some space. And then that'll be a minus, and then secant x all squared is the same as secant squared x. You can write it like that. It does save a little bit of space. You don't need the parentheses. So there's the setup. And I'd like to go ahead and do that integral as well. Let's see. It actually is a pretty fun integral to do, because there's a secant squared, and that's a familiar derivative. It just comes from tangent. So we can pull out the pi, and then 4 becomes 4x. So you have pi. Then we have 4x. And secant squared came from tangent, so that's just minus tangent x. I take the derivative to double check that and keep the pi, and then 4x goes to 4 and tangent goes to secant squared. And then that's from negative pi over 3 to positive pi over 3. And now you can plug in the pi over 3 to both, and the negative pi over 3 to both. And tangent of pi over 3. For that, you can look at the sine divided by the cosine. So you've got square root of 3 over 2 divided by a half. Comes out to square root of 3. And then for negative pi over 3, the sign will also be negative square root of 3. So I think I'll work the rest of this on paper though, because running out of space. And I might also point out that you could use some symmetry here. This has the same amount of area and the same amount of volume from negative pi over 3 to 0 as it does from 0 to pi over 3. So by just looking at the symmetry of it, and for that we need to know that secant is a symmetric function, we could write this as pi times 2 times 4x minus tangent x from 0 to pi over 3. That goes in, that goes a little faster so that you can don't have to plug in every single number there. And let's see, still need a little more space to show my work there, I think. But now I can squeeze it in small. Maybe I won't even bother simplifying it, because you get 4 pi over 3 and then minus the square root of 3, but then plugging in 0 to both gives you 0 and 0. So you can get just, well, that'll be 8 pi squared over 3, multiplying the 2 pi on both, and then minus 2 pi times the square root of 3. And then you have to plug in 0, but both of those will be 0 because tangent of 0 is 0. So you get minus 0. So there's the final answer. Alright, I did do some work in my head there. I'll show a little bit more work on the paper if you want to see that. But that should do it pretty well.